right, so let's jump into types. So in this module, we're going to cover basically 5 different aspects of types. One is what are they? Secondly, why is typing important? The third will be what the primary variable types are. So there are quite a few types in Swift, but there are 4 primary ones that we'll discuss in this module that the students will use early on. How do we declare them? And so declaring a variable or a constant of a particular type. And then finally, a concept called type inference and what type inference is. So let's jump in. So first of all, I want to expand our Post-it note analogy a little bit. And we now have Post-it notes of different colors. So before we just had one kind of Post-it note, which represented a variable or a constant to hold a value. Now we have Post-it notes of different colors. And each color in this analogy basically implies that a color can hold a particular type of value. So we're actually looking at different types of values now and saying that, well, only the purple value should go into the purple Post-it note and only the green should go to the green and so forth. So let's look at the 4 primary types for Swift. The first one is int. And this right here, int, int, is exactly how it's spelled with a capital I. All of the types will start with a capital letter. And int represents basically integers. And integers can be represented as simple numbers with no decimal. And it could be positive or negative or 0, but that's an int. The next one is a double. So here we have a double. And a double is like a floating point number. And essentially, it's a throwback to basically the size of the amount of memory used to store the variable. But suffice it to say for Swift, we're going to use the term double. And when we say double, we mean a floating point number. So in this case, like 3.14, remember that was pi, or 9.8. I guess the question is, did anybody know what 9.8 stands for? And the little thought there is 9.8 meters per second squared is gravity, Earth's gravity. The third one is a bool, and that's short for Boolean. And so it's just represented as BOOL. And it's very simple. It can have a value of true or it can have a value of false. And then finally, string, which we'll use quite a bit. Strings, we've already sort of been introduced to indirectly when we've done our first print hello world. But essentially, strings are what they imply and look like. They're literally a collection of characters that represent a sentence or something that we're going to communicate to the user typically, or what the user has communicated back to us. So when we're declaring a variable of a particular type, we're going to start with, first of all, where we are today. So we already know how to do this, right? We declare a variable by starting with var. Var implies variable. And then we have some particular variable name. In this case, I'm using pi. And then remember, equal means gets the value of. And then finally, the value itself. In this case, 3.1415. Again, approximation of the value of pi. So we know how to do this and declare it, but what I want to do is show you how to do this where we're actually specifying the type when we do it. And the way we do that is we add this colon right here, and then we put the type name here. So this could be int, it could be Boolean or bool, it could be double, or it could be string, the 4 that we've already identified. In this case, because this is a floating point number, we want to put double here, and that's how we actually declare variables of particular types in Swift. Again, it's by adding the colon and the type. So what is the type of this variable? So when we think about this particular one where we had it before, var pi equals, we didn't specify a type there. So did it have a type? Do we think that it had a type, or do we think that it was typeless? Could be anything. So that would be a question for the class to kind of think through and talk about. In this case, it actually does have a type, even though we didn't specify it. And the way this works is that the compiler, our friendly compiler, looks at this value and says, well, hey, that looks like a floating point number, so that's a double. So basically, I am going to infer that this variable here is of type double. So even though we didn't specify it, we actually still declared a variable of a particular type, thanks to our friendly compiler that's working with us and ensuring that this type is now double. So it is perfectly correct to not specify double when you declare it if you're giving it a value right at the time, and it can infer from this what type it should be. So let's look at declaring variables of different types. So for example, if I'm going to declare an int, I'm going to do it this way. So I've got the var, I've got a variable name, and here's that colon, and then the variable, the type itself, int, and then 8. And so we've put now an 8 in our post-it note that goes with integers. Here's a second one, gravity. So gravity is a double, and here we have 9.8 or meters per second for gravity, the acceleration rate here on Earth. The third one is exists. So this is a question, does something exist or not, true or false? And therefore we have colon Boolean as our type. And then finally, string, hello world, we're used to that. And we're going to put a string on our post-it note here that's allocated for strings, and we say colon string here. So this is how we're declaring variables of different types. What do we think will happen if we write an 8 on a post-it note that's supposed to be for Booleans, for true and false? So again, to the class, any ideas on what we think might happen? Do we think that Swift will just accept it and change the type on us? Would it change the color of the post-it note to be the color of the purple post-it note to match the variable? Or do we think there might be another issue? So the right answer is that there is another issue. So basically, our friendly compiler that is sitting there right next to us, our partner in crime, so to speak, is looking at this and saying, you know what, you can't put an 8 here because that post-it note is reserved for Booleans. And we will get an error from our compiler. And that's a good thing. So that's going to prevent us from making mistakes in our code that could cause problems down the road. So I want to try one more quick analogy with you. So we did it with the post-it notes. Here's another one that hopefully will be help sort of solidify typing. So imagine we have a house and we have a garage. And these are two different types of buildings. Notice I use the word type there. And a house is actually built from a blueprint for a house. So there's some architectural blueprint made to basically build a house. And there's a different architectural blueprint made to build a garage. So what's interesting about this is these blueprints, if you will, describe how something is built, a container, how that container is actually constructed. And it kind of implies the types of things that might go in it. And the same thing for this blueprint, this defined garages and what types of things might go in those. So when we come along here and we say, okay, we have a car, where do we think the car should go? Where is it okay to put the car? So again, question to the students on that. So after the discussion, hopefully everybody's determined that the car needs to go in the garage, right? So imagine this is some container, a garage, and it contained a value, which is the car, and the car went into the garage. So what about the next thing? So where can we store, so here's a kitchen as an example. So where does the kitchen go? Well, we probably, again, through discussion, we can sort of throw out ideas, but the whole idea is that eventually the kitchen's going to go into the house. It's not going to go into the garage. And so those are two valid places for two different types of things to go in two different types of containers or enclosures, if you will. And so what about this? What would happen if we took the car and we tried to put it in the house? Well, that might cause a lot of damage because, first of all, the house doesn't have any doors wide enough to take a car, so you'd have to kind of smash through the front door to put the car in there. It would really be very inappropriate. The house was not built for a car. The blueprint over here was not built up to allow a car to be in the house itself. And so again, this is where our compiler friend comes to the rescue and saves us from doing that and says, nope, you cannot drive a car into the front door of your house. So when we look at this analogy, asking a class, what is a variable? So of these things, which one is the variable itself? And again, the variable is something that is like an enclosure, it has a name, and it's going to encapsulate something. And so hopefully they say that the house and the garage are the variables themselves. And of course, their names might be their addresses. Secondly, which is the type? So the type is how it's constructed. What is it allowed to hold? And in that case, hopefully they see that it is the blueprints. The blueprints are your types. So a type is like a blueprint for what the variable is going to hold. And then third, which is the value? Well, you only have one element left to pick from, and these are the variables. So the variable values. So these are the values that are going to go in, such as a kitchen, a car, and so forth. So hopefully that analogy also helps sink in what types really are. So what we've done with types is we've looked at what variable types are. We've talked about that. And we've talked about the 4 that we have, right? So that's string, bool, float, which is double, and int. And then we've talked about why typing is important, right? We don't want to drive our car into the middle of the house. We don't want to put a integer value on a Post-it note that's only supposed to be for Boolean values. And so this is what we refer to as type safety. And this is something that will be very beneficial in coding down the line to keep us from coding in bugs and errors. What are the primary variable types? We've just described those. Fourth is how do we declare a variable of a type? So we know we do colon and the type name after the variable name. And that's how we do that. And then finally, what is type inference? So type inference was basically saying that we don't have to declare a type if we're assigning it a value right when we declare it, and the compiler, our compiler friend, can help us figure out what that type should be. It'll be typed due to type inference. And that's types.